Hello, everyone. Welcome back to OneTAKE Live, the show where we discuss the future of work, life, and culture with visionaries, entrepreneurs, game changers. I'm your host, Ian Barkin, and I am thrilled to say today's guest fits all of those criteria: the visionary, the entrepreneur, the game changer. He's also a friend, a former classmate, and I'm not going to waste any time bringing him on. I want to welcome Inder Singh to OneTAKE Live. Inder, welcome to the show.
Ian, thanks for having me. It's great to see you.
It is awesome to see you. Okay, so Inder, we're going to talk about this incredible journey that you've had. You are now the founder and CEO of a company called Kinsa Health, and we're going to get there in a moment. But before that, I want to talk about some of your background and ultimately the inspiration that you had to found Kinsa. Before I get started, I do also want to say I've done about 65 of these shows so far. 65 one takes. And to my knowledge, you are the first guest who is also a cover model. You're my first cover model guest. So it begs the question, this is the MIT News alumni newsletter. Look, we even have a graphic. It begs the question, Inder, and I mean this in all sincerity, is that Photoshopped?
It is certainly Photoshopped. It was taken in front of my house.
Okay, because you're a handsome man, but I mean, you look great in that, and you've set the aspirational bar for good-looking entrepreneurs too high, and it's making me self-conscious. Okay, I've gotten that off my chest. So let's start with a bit of your background. We both went to Sloan together, MIT Sloan. We were getting our MBA together. You were one of our classmates who was both brilliant, energetic, a great guy, and also someone seemingly who had been stuck in school for perhaps forever. Quick stop tour through that if you want to, but ultimately, what did you do after school? Because that really gets us going on the context and the Kinsa story.
Yeah, I have too many academic degrees. I spent a lot of time in school up in the Boston area for graduate school with you and with others. It was great. But after school, I had the pleasure of working in public health. I joined an organization called the Clinton Foundation and spent the next almost 6 years there working on issues of global public health. So I think I had the greatest job in healthcare, bar none. I ran around the world and I brokered deals between a consortium of 70 developing countries and the CEO or owners of pharmaceutical companies or diagnostics companies who are making life-saving drugs or diagnostics for AIDS, TB, and malaria. My job was to improve the quality of and reduce the price of drugs so that we can improve access to these essential medicines. It was a dream job. I literally lived out of a suitcase and with President Clinton's entree would speak to the CEO or owner of these companies. But then it became very much a business issue. How do we work together to improve access? Over the course of 5 years, we had great impact. It was a dream job. I loved every moment of it. And I had the honor of being the person who brokered the deals that dropped the price of drugs for AIDS, TB, and malaria. For AIDS, it was over 90% in that course of 5 years. And we introduced 40 new drug types, drug formulations for rare pediatric conditions. And as part of that effort, I had the pleasure of helping. I was one of the co-runners of the largest pediatric HIV program in the world with 600,000 children. It was awesome. I loved it. I got really frustrated at the end of my tenure at the Clinton Foundation because I saw the way the world really works when it comes to stopping the spread of infectious illness.
Okay.
And the sad fact is that we do it with zero information about where and when it's starting. So I'll pose the question that I posed, 9 years ago when I started Kinsa to you now, which is, how do you stop an outbreak before it becomes an epidemic or, God forbid, a pandemic if you don't know where and when it's starting? And the answer to that question is you don't.
Right. And
over the last year and a half, we all know that intimately. I'm not sure that people really understood it prior to the pandemic, but now everybody understands that.
Absolutely. So, and perfect. And that gets us up to the Kinsa story. And I want to talk to you just about that the spark, the inspiration of what took you from and living in a suitcase, traveling the world, brokering big, meaningful deals that the byproduct of those deals was survival, was health, was safety, was livelihood, to then deciding product company startup is for me. So what was that inspiration? What set you on the path to Kinsa?
There were two things that occurred. So the first, without disclosing any sensitive information, was, I was at a meeting of a major global health donor. And I remember seeing the information. People would get up, and this is the final meeting before they were allocating almost $300 million to infectious disease. This is a major global health donor. And, people would get up, give their 2 or 3 minute spiel about what they thought. And to be clear, the whole process had taken a year, but this was the final meeting and people were giving their final comments. And I remember the head of the World Health Organization, one of the divisions of the World Health Organization, came up and said, there are this many cases of this disease in the world, and here's where they are. And I said, oh, I know that data. I know that data well. It's the data I cite. And then, I look down my notes to see the information, and I see that well-known professor at another university says, no, there are this many cases of this disease in the world, and here's where they are. And this happened to be around malaria. And I was like, wait a second, it's a well-characterized disease. What are you talking about? How are we not operating from the same base of assumptions? If you don't know where to target your interventions,
right?
How are you going to get drugs and diagnostics to the people who need them so you can curb illness? And I got really frustrated. I'm a very impatient individual, which makes me a good entrepreneur, a questionable husband at times in terms of my impatience. But I was very impatient. I remember looking down at my phone and I was looking at Google Maps being like, I need to get to my next meeting and figure out what's going to go on here. I'm a little frustrated by listening to this. And it dawned on me that we have so much real-time data in the world. We have real-time data about how to get downtown. We have real-time data about what our neighbor's house costs through some of these online services. We have all sorts of real-time data, but we didn't have real-time data about this core question of what's going around.
Right.
And that affected the system, right? Because the system can't respond to outbreaks and infectious disease if they don't have information. But I came to learn when I became a parent that what's going around question is also a very personal one. It's the first question that a parent asks when you have young kids who starts getting the sniffles or a sore throat, is not feeling well. What's going around? Is that going to evolve into strep throat? Is that going to evolve into the flu, or God forbid something worse? Do I take a day off? What's going around, right? It's a question that is asked at a personal level. It's a question that's asked at a system level. And that kind of led me down this path of asking a whole bunch of questions to a whole bunch of people, saying, we've got to be able to do this better. We've got to be able to do outbreak identification better. We've got to be able to forecast who's going to be affected by these things. And I came to learn that the data just didn't exist. It just didn't exist in the world. People were using things like sales data, sales of drugs off the shelf, which is helpful in some ways, but not predictive, right? And it's too late. By the time you're going to buy a drug, it's already spread in the community. People were using healthcare data. And healthcare data is very interesting, but the challenge with healthcare data is it's too late and it's not granular enough. And this may be surprising to people, but I think this is a really important point. Why did we not catch COVID-19 earlier in the country? Right. Why are we not able to get ahead of flu outbreaks, which kill 40,000 to 80,000 Americans each year, often the elderly and often the chronically ill? But why are we not able to get ahead of it? Well, that's an important thing to think about. And that was one of the things that we thought a lot about at Kinsa when we were trying to develop our system to get novel data to do outbreak detection and forecasting.
Right.
And so let's talk about that for a moment, right? Yep. Let's talk about COVID. Person one in the household gets sick, but they have mild fleeting symptoms. They never go see the doctor. They never go get a lab test. Person two in the household maybe gets sick from person one, but it's totally asymptomatic. We hear about asymptomatic transmission all the time in COVID-19. That's true of many, many, many infectious diseases, right? So they never get sick. They never go see the doctor. They never, go to to get a test. Person three gets sick. And finally, after an incubation period, they get sick enough and they're like, I got symptoms. in the latest IDC CDC, 5 to 8 days later, they actually get a test. By that time, it's too late.
Right.
COVID is spread in the community, and those individuals have perhaps accidentally, spread it to others. Right. It's too late. So we said, how do we get to those people who are mildly symptomatic? How do we talk to those people, those households that have mildly symptomatic people, in order to get the data needed to do outbreak detection and forecasting? And that's where Kinsa was born. It was that kind of concept.
Brilliant. So a lot to unpack or summarize, but the idea of, as a parent, you sort of knew there was this instinctual, situational need for awareness of what's going around. You had platforms of technology that presented themselves and allowed you to build on top of them. And you saw from your prior work at the Clinton Foundation that data was just tenuous at best and wasn't defensible, so that you could actually build solid policy and plans around. So you become a med tech startup guy. And we'll go back to the beginning, because Kinsa started 2012. Is that correct?
That's right.
Okay. And I remember, and I was very excited to see this. You were one of my first friends who had an Indiegogo campaign, and it was actually fun. I was checking through my email archives, and I realized it was actually this is sort of strange, but 11 days from now, 8 years ago. So it was April 17th, 2013. I got the note for thanking me for backing your Indiegogo campaign, your first one. I, of course, bring that up completely for the credit. I just want the credit for that. No,
well,
but
you were one of our biggest backers, to be clear. You were one of our biggest backers in that first Indiegogo campaign. You believed day one, and I'm grateful.
Thank you. I didn't actually mean to bring it up for credit, but I do passionately remember, that you backed the jockey and you couldn't have been a better one. The idea was exciting. The early form factor just plugged into a phone, so you were really playing off just the smart device that all parents had at their disposal at the time. But those are the early days, and then you've evolved since. You've had another Indiegogo campaign about 2 years later. I checked. I have an email for September 2015 for that one. And ultimately, you have a product that's in store shelves. I mean, you got out to Apple, you're in Target. I mean, blows my mind how cool that is. But what's so much cooler is that it was a foundational piece to a grander. Oh, there you go. Look at this. We're both product placing. So I do want to bring up one point, Inder. It says on the box that this is recommended by 9 out of 10 pediatricians. And so the question is, do you know who that 10th pediatrician is? And would you like me to speak to them? Because I'll call them up right here on the show if that's valuable at all to you. But it was just a piece of a grander thesis, right? As you said, it was it was a means to an end, which was reliable data to create that situational awareness to then do something with. So I've done a lot of talking, which is not the best characteristic of an interviewer on a show. So I will shut up in a moment. Before I do, I will do my duty as a live streaming host and thank so many people for joining us. So bear with me for a second. But I do want to say thanks to Jim McLeod, to Shay, AJ, Sunita from Mumbai. Hello, Shay from Boston. Dave Reichman from Salt Lake City, Arnold from Monterrey, Mexico. Hello, sir. Mark from London, Russ from Tampa. Thank you guys all for joining. Do share questions if they occur. And if you haven't shared your name and location, please do so. And I will read it out to prove that this is live. So, okay. So Inder, you've got product and you're getting out to market. I want to explore sort of a triptych, if you will. There's the patient, there's that parent who you're selling this product to and the purpose of that. And then there's the broader community and public health role that you play and partnership that you have. But let's start with the patient first and foremost. So what's the end-to-end sort of customer lifecycle journey, which is such a cheesy way of putting it, but you know what I mean? Like, as you said, your kid's got a cough or they wake up in the morning and they feel a little warm. Walk me through how Kinsa fits into that parent healthcare journey for their child?
Well, let's take a step back. So for a moment, for the way we thought about how do we get data, how do we collect and aggregate data from people who have just fallen ill, and how do we get specific kinds of data sets? Where and when are they falling ill? How fast is it spreading? How bad is it, right? If you want to know outbreak, if you want to do outbreak detection and forecasting, this isn't rocket science. You got to know where and when things are starting, how fast they're spreading, and how bad they are, right? Really simple.
Perfect.
So the way we did that was by reimagining the only product that exists in the home that someone turns to when illness strikes, and that's the thermometer. So the thermometer allowed us to create a communication channel to a household when they first fell ill, a two-way communication channel. And what we did was we turned the thermometer into a connected product. And people who aren't familiar with smart thermometers are gonna be like, okay, everybody's connecting every kind of product in the world to the internet. Why and how is this gonna be helpful to me? The whole idea here is it's not really a thermometer. What it really is a medical guidance application. So you get a temperature, you answer a series of questions about what other symptoms you have, and it helps you determine, do you go see the doctor, or do you go to the emergency room, or is home care okay? And it helps guide you for the next step too. Okay, I took a temperature, 4 hours ago. Should I take another one? And what do I do now, right? So that's the whole idea behind the application, is you piggyback off the behavior to help people answer the questions they really care about in that moment, which is, what do I do? How bad is it? And what's going around? And so, that's kind of the way the product works.
Right.
Now,
just to jump in, because it says it on the box, real time. Let's see if the focus will get it. There we go. Real time guidance. So effectively, if I'm a parent and my kid does have a temperature, it's more than simply saying the number is higher than mentally I remember it should be. There is 98 point something, but then that's when you engage. That's when the application walks them through, asks additional follow-up questions, and starts to. You stated clearly you're not the physician, but you give them some directional guidance as to what to do next. You're effectively doing precision learning at a point in a point of care life cycle where the parent needs help the most.
Exactly. They're making those early decisions before they enter the healthcare system. What do I do? And that's the whole idea behind it. It's comforting. It gives you peace of mind. It reassures you, and it helps you make those early decisions.
Perfect. So that's the parent in their household, but this thing's connected. So the natural next question is, what are you sharing? Does the world now know that my kid has a fever, or is it somewhat more sanitized than that?
Yeah, so the user's data is the user's data. It is fully privacy protected. We do not do anything with the user data except aggregate it up. So to be clear, what we're displaying at, for example, healthweather.us, which is where we show trends in illness. You can go to healthweather.us and get your local illness risk level. So you can find out if there's a high level of illness or a low level of illness and what you could be, at risk for. But what we do there is show data at an aggregated geographic level. Think about it as the percentage of people sick on a county by county basis. Let's talk data for a second, right? That is an inference. It says it's not possible to identify an individual based on an inference like that, the percent of people ill in a big geography. Right. So this is not personal data. This is not de-identified data. This is not metadata about a person. This is aggregated inference. And that's, I think, one of the reasons why users feel comfortable using our products is because it is fully privacy protected. Right. But that's the whole idea. Is if we can get a whole bunch of people, if we can get millions of households to use the product, now we get to see where and when symptoms are starting and how fast they're spreading. Perfect. And you can think about it on a heat map. And again, go to healthweather.us and there's a whole bunch of heat maps you can take a look at.
Right. And quite literally a map of heat, in so much as people are warmer. I like it. So let's take it. And this is pre-COVID for a moment, just for sake of context. So this is before COVID. The primary, the indicator inference that you were tracking was still temperature through a thermometer, but it was often to indicate flu. and so you've got individuals in their homes, but then how does that apply to the community? And so you extend now, and you have programs with schools, local healthcare providers. Talk about the work that you do with schools.
Yeah, so today we're in about 5% of US elementary schools. Today we ingest other data sets beyond ours. Today we were able, at the beginning of March when COVID first struck the country, what we saw was very unusual. We saw a rise in febrile illness, a rise in transmission levels when we were expecting it to fall.
Right.
And it happened in many parts of the country. And so that was our indicator, especially when it was above, top data. We're basically taking a real-time signal and we're subtracting out what you'd ordinarily expect from cold and flu season.
Okay.
What's left over is unusual. What's left over was an unusual outbreak, and we were seeing it in New York City, throughout the Northeast, in Florida, parts of Texas, Michigan, Florida, Washington. We were seeing a black swan event where we were seeing unusual outbreaks everywhere.
Okay.
And at this particular point in time, this was when there were only initial cases in California. There was like a couple cases in California and Washington.
Right.
So this was the detection of COVID. But the reason we were able to detect COVID goes back to your point, to pre-COVID days. So for years, we've been getting more and more users on our system. We had 1 million+ households on our system for a couple years.
It's tremendous.
And what we were doing was fingerprinting illness spread, seasonal illness spread, flu spread across the country on a location by location basis. We were looking at how it spreads differentially between, a place like Minneapolis versus a place like Atlanta,
okay,
and developing methods and algorithms that could predict that over time. So just prior to COVID, we had a big breakthrough when we could start predicting flu spread months in advance. Today, we can predict flu spread up to 30 weeks in advance at the beginning of the season. So like sometime in October, we can predict the rest of flu season and how bad it's going to be, where it's going to be bad, what the incidence curve is going to look like, how many people are going to get sick when. And that gave us a huge leg up for COVID, because again, now you've got this big forecast. So you can subtract the forecast from what you're seeing in real time, and what's left over is unusual. And so that's kind of the way that the work prior to COVID and the work during COVID links together.
Perfect. Okay. Well, so
but to your point,
yeah.
Sorry, go ahead. I was going to say, to your point, one of the reasons why we were able to do this is because we've been working with millions of households and thousands of schools across the country. So at the community level, what a school nurse is now able to see is the trends in illness at the school. Like, is the school level of illness going up? Households associated with that school, is the level of illness going up? Is it going down? What kind of illness is it? Is it severe? Is it not severe? And we crowdsource information from the school to give everyone a picture of that. That picture goes to the nurse, but it also goes to the parent. The parent gets to see, if you opt in, you get full access to the kind of aggregated insights.
Right.
So it's a give-get, like you participate, and now I get to see, is the level of illness in my child's grade high or low, and what's going around to help further guide you on that question that you ask when your child falls ill. What do I do? Right.
Right. And to use a Clintonism, it takes a village, and you've now informed the whole village so that the school nurse and the parent are all on the same page, and they're being fed the appropriate response behavior to keeping kids home, or stocking up on, or going to get the flu vaccine, et cetera. So
yeah. And that's important, just to be clear. Like, one of the questions people ask us often is, well, okay, you had this small study that showed a 27% decrease in illness-based absenteeism in schools. That's big. How is it happening? And, how is that working? And we have a lot of hypotheses about how it's working. But our belief is that if you give people data, if you give people insights, they're easy to digest. Hey, the level of illness in your child's grade is going up, and it has these attributes, and there's 2 reports of strep throat. Well, they're going to respond appropriately. Like if I got that information and my child had a sore throat, just had the development of sore throat, gosh, I'm going to get down to the doctor way faster than if it wasn't, if there was no reports of strep throat, or if it wasn't concerning, right? That I'm just going to respond very differently.
Right.
And that's the thing here. You're democratizing access to insights, not access to people's information, but access to insights. And as a result of that, they're responding, and they're responding well. And it doesn't take a lot of prompting for us to sort of say, hey, go do this. People know naturally what to do in that case. But what they've never been equipped with is that kind of insight. They've never been equipped with that before.
Right.
And if you don't, I'll comment on COVID for a second. Like, I can't imagine how hard it is for a school leader today who is trying to make decisions about keeping schools open, about closing them down, who's probably getting berated by one party or another saying, I need the school to be open, or I need the school. Like, they're probably, like, they feel like, I'm sure there's a lot of like difficulty making those decisions. They're doing it based on expert opinion and guidance and policy, but they're doing it without real-time data. And now you have real-time data to say, I made this decision and here's why, right? Parents have that kind of information to make decisions about whether they send their kids to school. Principals and superintendents have this kind of data. That's the power of a system like this, where you can aggregate the data up and give it back to the people who are making decisions, and they're good at making decisions. They just need a little bit of information, a little bit of insight to make those decisions. And that's why it's so important. We believe the school program is so important today under COVID.
Brilliant. There's a lot I want to go back to later in our discussion around making that data available and the democratization of that insight. Before we do though, so if you take, again, pre-COVID, these are flu cases where parents now have the capability to measure with devices on platforms they have available to them. The communities, the local principals, the nurses, the local pediatricians have that information. You referenced policymakers. So then you boil back up to, the group that you hung out with during that inspirational set of moments at the Clinton Foundation, where you realized the data was tenuous at best to base policy on. How are you working? I guess, again, pre-COVID, because then we'll get to all the same questions during COVID. But pre-COVID, how are you working with policymakers to make that data available? Because you could just as easily make a good thermometer, sell it at Target, be happy, go home every day, spend time with your family. But you have not settled for that easy goal. You're trying to change the world by democratizing this insight. What sort of work have you done with policymakers to give them this information and to evaluate it for them and with them?
Prior to COVID, there wasn't as much work as we would have liked.
Okay.
Listen, we were doing something very novel and very different than the way that existing public health systems worked.
Got it.
And it was challenging to get people to listen to us.
Okay. So let's pivot then, so you wrote a blog, and we'll put a link to it somewhere in the notes, but you wrote a blog in which you said infectious diseases continue to be one of the greatest public health concerns across the globe. And you wrote that in September of 2017. And joke's on you, nothing's happened since then. We're all fine. Oops, sorry. So COVID. So the attention you were trying to draw to infectious diseases having potentially catastrophic effects globally, COVID gave us the benefit. And frankly, it's deadly, but it could have been a hell of a lot more deadly. So maybe there's a silver lining to it, which is it woke a lot of people up. So now let's go into Kinsa during COVID. So let's go back to the patient for a moment. So you now have additional resources available to families, same thermometer, same thing you're measuring, but talk about sort of how you got together with your team and decided, okay, we got to rally the troops and to add to the platform to answer the call at this moment in time.
Yeah. So from the patient level, there's a lot more information in there about, risk levels in your local area. There was a lot of data science that we did with a number of academic institutions early on in the pandemic to prove that what we were seeing, these atypical outbreaks, was actually COVID.
Right.
So
there was a
great New York
pushback.
Times.
I mean, I've read some that people said, yeah, you're full of it. This you can't mean it. There, people are fine. What was that story? Because you like you did with flu, were predicting well before anyone actually saw the numbers show up in hospitals.
Yeah, we were very careful at the beginning of the pandemic because there wasn't widespread testing there weren't even case counts in many of the places we were calling hotspots. They literally didn't even have first cases. On average, we were picking up first cases somewhere between 10 and 14 days before the case actually was identified, first cases. So people were, questioning whether this was really predictive of COVID. And time told, right? I mean, lo and behold, like weeks later, if you map our data, and there's actually this great New York Times article where they pulled all of our data down from every single state in the country, and they looked at our atypical illness signal, our unusual outbreak signal. And if you map that to COVID deaths 18 days later, so you take our data and you displace it back 18 days, it's almost a perfect match in every single state in the country. And in New York City in particular, it was like a perfect match. So we were definitely picking up community spread of COVID before the healthcare system was identifying cases. And again, let's go back to that very first premise. By the time the healthcare system sees a case, it's too late and spread has occurred. If, however, you can get ahead of the game and you can talk to people when they first are mildly symptomatic, you now have the potential ability to swoop in and contain an outbreak to a small geographic area, send the test kits in, send the virologist in. It's like a light bulb going off on the map saying there's an outbreak, and there's another light bulb going off on the map saying, hey, it's unusual. Send the test kits in, send the virologist in. And that's, I think, the equation for us to get ahead of these kinds of outbreaks in the future. I'm going to comment on one thing. You mentioned that blog post in September 2017. In 2017, 2018 was one of the worst flu seasons on record. 80,000 Americans died. There were tents outside of emergency rooms in the Southeast, in Atlanta and elsewhere. And, that was our first big story because we predicted, on the New York Times ran an article on this, we predicted that it was going to be one of the worst flu seasons on record months before the CDC came out and said that. Now, the CDC is conservative and they want to make sure that they're giving you correct information. We're a little bit more, forthcoming with that kind of prognosis. But the point here is that this kind of data can be powerful. And it's really important for us to think about these kinds of methods. It doesn't need to be Kinsa specific data, but these kinds of approaches for public health going forward, not just for COVID, but for flu years. Right.
No, that's important. So let's take it forward again. So we got the COVID reality. You've got, and I want you to expand a little bit on the health weather concept, because then I'll call up some graphics as you talk, because we pulled some from health weather just today, because I want you to sort of further explain what it is what we see and what you've made available that does portend to be trend coming forward. So the backstory behind health weather and putting that resource out publicly.
Yeah, I remember, we heard about first case counts in King County and Santa Clara County at the beginning of March. And, I asked my data science team, let's go look for unusual outbreaks. Let's take this method that we've thought of in the past. Let's go look at it. And we saw the United States lighting up in many parts of the country.
Right.
And so my first question is, has this happened before? Like, is this truly unusual? So we went back through 6 years of data. And yes, we've seen this kind of event occur before, but very limited timeframes and very limited locations. Like we found an anomalous flu B outbreak in Texas and in Minneapolis the year before. So it's definitely happened. And incidentally, whenever we looked at that data, it was confirmed. It was a flu B outbreak. Months later, we find that in the data that it was actually a flu B outbreak. So we looked very closely at our data, and my concern is heightened. I'm like, it looks like there's an unusual outbreak. It looks like COVID-19 everywhere, like many, many parts of the country, when we've only seen like small case numbers, very, very small case numbers in King County and Santa Clara.
Right.
So I called one of my advisors. I called the former New York State Health Commissioner, Dr. Nirav Shah, who's been a wonderful advisor to us. And we laid the data out. And he said, hold on 1 second, let's jump on the call in 10 more minutes. And he called a former head of the FDA. He called someone who helped Taiwan, was in the process of helping Taiwan respond to COVID-19 successfully during that wave one. So we're on this phone call. It was a Saturday night. We're on this phone call with these three experts, our scientists, our outside scientists, all talking through, gosh, are we seeing COVID everywhere? Do we need to raise the red flag? And the conclusion of that conversation was, sorry guys, what you're saying is not credible. There's no case counts anywhere else. Go back and do your homework.
Yeah.
So we did. We spent days, a couple days, it was like 3-4 days, just poring over the data with external scientists, with our scientists, and we couldn't find any errors in the analysis. So on March 18th, I made a call, which is we need to launch this. And we need to expose the world to this information that COVID is in many places, and go to those local municipalities and those local states and tell them you have a very high probability that there's a high hotspot here.
Right.
The team launched a product that would have ordinarily taken 9 months to launch in 36 hours. It was pretty insane how fast they were. And that was Health Weather was launched. That day, a number of people picked up the information. We had been talking to a reporter at the New York Times, Donald McNeil, for years, and he actually listened. He was listening, like he believed us because we've been talking to him for years. And I remember that night, Donald did a big profile article in the New York Times, and Rachel Maddow carried a long segment on it, and we started getting attention. Now, for me as an entrepreneur, that was wonderful, right? Hey, we've proven the concept, it's working. For me as a former public health person, it was very frustrating because the next several weeks, people were looking at us with interest, but they weren't taking action based on the data. They weren't changing policy. They weren't activating. We were unknown, right? We were unknown and we were small, and we were still building up credibility. And it was a new way of doing things that was foreign to my epidemiological and public health colleagues. You're getting thermometer data and you're overlaying this. And so like there was a lot of research going on. And now, starting like Q4 is when we started really, Q3, Q4 is when we started really seeing people take action. We've been working with states and cities for a while to inform them, but it's always hard to, filter through as to whether you're actually affecting a change.
Right.
But we're starting to see that just now. But it was very frustrating for months, very frustrating.
Interesting. So I pulled some graphics just to show off that what you were talking about. So as far as health weather, we'll put up a graphic of the United States and health weather. This is from this morning. That shows some places are calm and some places are a little warm, and two places appear to be very hot. But a perfect example, as you say, of democratizing access to insight, that if people believe in it, if there is trust, then they'll act appropriately on it. The next one I'll show is Florida, just because I live here. So Hillsborough County suggests that it's somewhat high risk. So and the site tells me what I should do and how I should take care. And I don't leave the house anyway, so I'll just hang out here by myself with my family. But does raise awareness. Now, the one I do want to point out is what the heck's going on with Michigan, because they seem to be a hotspot. So walk us through, with this information and insight now, what are your recommendations for Michigan and the specific counties that are lit up as critical? What should they do next?
Yeah, so I will say this is the specific things that a locality needs to do has to take into account a lot of considerations. Some of these are the political will of the people. Some of these are what's the right thing in terms of public health.
Right.
But from our perspective, our job at Kinsa is to equip you with synthesized, easy to understand insights and data so that you can make decisions. I'm going to give you one very, very interesting example of something that is unusual from my perspective. In New York City, what we found everywhere in the country after people issued aggressive social distancing policies, stay-at-home orders, restaurant closures in Florida, for example, you could see in our data within days, 3 to 7 days, that transmission levels would change. They would level off and start falling. It was really interesting because, again, governors, mayors, they're making decisions that pit livelihoods versus lives. And they're doing it based on expert guidance, but they're doing it without rapid feedback, without real-time data. Right? By the time the case counts change, it's been weeks or months. That's too delayed. Right. What we were seeing in our data was within days, transmission was changing, within days. And what we saw was very interesting. The speed at which case transmission fell was a measure of how effective that policy was. So let's take New York City as an example. In New York City, the slope of transmission, the decrease in transmission, was not nearly as steep as it was in other places. But they had an aggressive social distancing policy. They said, stay at home.
Right.
Now, we can only hypothesize about why that was less steep than other places. I believe it's because it's really hard to do aggressive social distancing in New York City. When you're talking about high density city and you live in a studio, you got to leave the studio every once in a while, right?
Right.
And so that was our hypothesis about what it was. But the point here is you had real-time data to evaluate the effectiveness of your policy. And for mayors, for governors, for public health leaders, that's incredibly valuable. So these are the kinds of things that make themselves available with a data set that's national. Like it's the same methodology everywhere. So you can compare city X to city Y, as opposed to the way that traditional public health is measured, is that the way you measure influenza-like illness, flu-like incidence, actually varies location by location.
Right.
So you've got this kind of apples to apples comparison, really simple, easy to use insights. And that, to me, is the future of epidemiology. It's the future of public health. It's how you get ahead of outbreaks. It's how you prevent the next COVID-19, the next Zika, the next, Ebola. This is how you do it, is by empowering a population in a bottoms up way, right? This is not a very top down approach that we're taking. It's very bottoms up. It's individuals collaborating, cooperating, participating, allowing their data to be aggregated while fully having their privacy protected. It's a network of cooperation. You want to solve any, if you don't mind me saying this, you want to solve any problem in the world, any big, hairy problem in the world, whether it's climate change or whether it's getting ahead of outbreaks, you need a coalition, a network of people who is cooperating and collaborating. And that's the core of what we've created. That's why privacy is so important to us. That's why giving insights back to the individual household is so important to us, because we want to make sure they want to participate, that they're part of the solution. And that's kind of that's the core asset that we built. A group of 2 million plus households who want to participate, who get the help they need in their moment of need, and are willing to allow their data to be aggregated for purposes of helping their communities respond, not just themselves.
Well, that's why I like the fluency program that you put in effect before COVID, and it was about the flu, but it brings to mind just general fluency as far as data fluency. And that's really the inherent foundation on everything you just said, which is, do you believe individuals, households, and all the way up to communities and politicians and policymakers, do you think inherently we have the data fluency to interpret this correctly, right? Because you can democratize access to data and ultimately to insight all day long, but if people aren't equipped with that sort of basic core set of principles and understanding the data, then there's only so far you can go. So I guess the question to culminate that long winding statement is, are we investing in the right education in schools and the right public messages from our local health and global health organizations to create that data fluency that you need to make that wide scale change?
I'm going to speak in a little bit of a technical way, right? Which is data-rich environments. There's a lot of data-rich, insights-poor environments that exist in the world. Right. And part of our job at Kinsa, and part of our job as public health, my job, the job of public health colleagues, is to make the data accessible. It's not data for data's sake. It's insight. So let's go to the school example. Again, if you see that there's a rising level of illness in first grade, and you see 2 cases of strep throat, are you going to change your response to your child who has that initial scratchy throat? Probably. And it needs to be boiled down to that level of simplicity. You take all this wonderful machine learning, data science, SIRS models on epidemiology, and you have to boil it down to the very digestible, very simple bites of information that people can use. And the different slices and dices and bites of information, they need to be different for different people. For the school nurse, for the household, for the sophisticated high-end public health analytics department is very different than the small city who, has limited budget and needs to know the basics. And that's our job, is to make sure that is digestible. That's the job of us. That's the job of our public health and epidemiological colleagues. But again, there's a lot of data-rich, insight-poor environments that exist in the world. Healthcare has these all over the place. Healthcare systems have these all over the place. Right. And the art form here is making it digestible.
And do you think we're on a trajectory where that's going to grow? I mean, if you think about, a smart connected thermometer is one of a class of med tech capabilities now. Everything from blood glucose monitors to the smartwatches and fitness trackers to smart scales to smart, heart rate monitors. Everything's becoming smart. And I imagine that if they follow in the same philosophy that you have with Kinsa, that information is anonymized and made available to then discern major trends that are happening and predict them. So more data and a demand to create more insight, and then, as you said, to distill a message that is appropriately positioned for the audience so that people act on it. So it's either simple and personal and motivational, or it's quantitative and defensible and interrogatable for the data scientists. So is that the way that we're going? And also, I guess I'll add another complexity. Is thermometers what you're going to focus on at Kinsa, or are there other devices that allow you to get a 360 view of personal health?
So first, I'll say to answer the first question, if we invest, because making things digestible is not an easy thing, right? There's science to it and there's art form to it, but this is where the rubber meets the road. If we, as a society, invest, and I'm trying to build a business here that enables that, but I've got to build bigger partnerships with state, local, and federal public health agencies to continue that work, because it's increasingly expensive when you're talking about operating at this scale. Right. And so, we need to figure out, do we have partners in the public health world who are willing to help invest in this area together? And it doesn't have to be, again, it's not just about Kinsa data. So listen, I'll make another point, which is, I think the world of wearables holds the future of healthcare. We need to go to people when they have a change in healthcare status, not ask people to come to us. This is kind of what we're doing with a smart thermometer already. But here's the challenge. Wearables are expensive and they're inaccessible by the key groups that are most affected by things like outbreaks. If you want to talk about public health and outbreaks specifically, one of the reasons our network works and the existing networks don't necessarily work, we don't know entirely if they work, but they probably don't. Why the Apple Watches, the Oura Rings, the Whoops, who are doing wonderful, wonderful work on individual health analysis. Right. But one of the reasons it doesn't work at an aggregate level is because they don't have the sentinel groups. They don't have the early warning groups, the groups that get sick early and spread it, larger households, underinsured, uninsured individuals, including those large multi-generational households where virus can just bounce around between people and then go flare up in the community, right? They don't have frontline workers necessarily. These products are wonderful steps forward. My hope is that Apple makes a product that is a $20 product and gives it away for free. Remember, through our school program, we give away products for free. Someone else pays for it. We give it away to Title I school communities, to underinsured. That's the reason our network was able to pick up this. It's not just this behavior. The behavior is critical, right? We're able to talk to people the earliest sign or symptoms. Wearables talk to people all day and all night. So they're going to pick up that early thing as well. But you've got to also be in the right groups. And so I think products like what you described hold the future of healthcare. But we've got to make sure that there is an access point for underinsured, for poor communities. Otherwise, we're missing the boat. As we've learned in the pandemic, we can only be healthier together. And that includes the adjacent communities next to us, because otherwise it's still going to be out there and it's going to just create another flare. We need to be healthier together. And I think that's one of the big points that I want to make around the specific work that we're doing on forecasting and containment of outbreaks.
Perfect. democratizing not only data and insights, but democratizing the technology and the platforms to gather that data and insight, especially from the communities that need it most.
Absolutely.
So, so much to we've run up to the end of our time. I do want to bring in three different things. One, GM from our class said hello, dropped in, and said hi.
Hey,
so,
GM.
Hi, GM. Thanks so much for making time to spend with us. AJ Hanna, who's part of my team, who focuses on healthcare. We actually have been publishing some reports on telehealth and telemedicine. We actually have some reports on medtech and its role in this. I think we basically covered it, AJ, but he said, with the explosive growth of telehealth usage, do you see Kinsa products connecting to telehealth platforms for monitoring purposes? So maybe we didn't cover that. What are your thoughts on that as far as connecting?
Absolutely. Yeah, absolutely. Telemedicine in the last year has taken, it's leaped forward 10 years, right? In the last year. And so we do see Kinsa as a telehealth tool, as an access point for telemedicine. Perfect. Right? Yeah. And so I think it's going to be important going forward.
Great. So, okay. So we did the founding story. We did Kinsa before COVID, during COVID, which truly has been spectacular to see how much work your team's done, the value you've created, the insight that you provided, and also the validation of your hypotheses and showing that really this data can be used to predict. So after COVID, hopefully one day soon, we're through the worst of this. I think you've already covered a lot of it, but what's on the horizon? What's next for you, for Kinsa? Are you looking to expand more internationally, working with other associations, policymakers? I'll give you the final word, and it is just sort of what's next, and what do you hope for Kinsa and for the world?
I mean, since inception, our goal has been to create a global early warning system, and that's what we're going to go try to do. Now we need to go scale the system up and build those partnerships and make sure we can get the funds to actually go do that. But that's our goal, and that's what we're going to go do.
Let's touch on the get the funds for a moment, because I don't want to leave before calling that out. So you'd said you've had sponsorships that have helped you get into certain schools. If people are listening and interested, where should they go to learn more about that? So right now we're working with a number of school districts who have received a lot of funding through the American Rescue Plan to try and stand up long-term school early warning systems. Okay.
We have a number of large school districts that we're working with. We also have a sponsored program. We're really grateful to Lysol in particular. Lysol has funded thousands of schools across the country to receive this program in a very innovative partnership. They're doing it for all the right reasons, because they believe it's the right thing to do. And I'm grateful to their support. So we do have a free program for Title I schools that you can apply to on a year-by-year basis. I think right now the question is, can we work with schools in a long-term way? And the value is pretty obvious that we've talked about, but we also think it's going to help them reduce their cost of testing, disinfecting, because you can now target those interventions to the right place, right? So that's the goal, is to work with those two entities as well as departments of public health.
Great. We'll put links to resources and sites for anybody who's interested in, who's listening to this after the live stream and wants to learn more about Kinsa, learn more about all of your great work, Inder, and learn about how they might be able to contribute to it. So with that, again, thank you, my friend. I am so impressed with all that you've accomplished, and so glad that you're here to help us to take care of ourselves, to democratize that insight and analytics so that we can make the world a healthier place, which we all dearly and personally want to have happen. And with that, thanks everyone for the great turnout for the show too. Thanks to all the listeners. And for anybody who tunes in later, thanks again for joining OneTAKE Live, and hope you're all healthy, safe, and well, and look forward to speaking with you again soon. Thanks everyone. Thanks, Inder.
Thanks, Ian.